This is question number 1 from the 2004 AP packet. The traffic flow is defined as the rate at which cars pass through an intersection measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f, defined by 82 plus 4 sine of t over 2 for the interval 0 to 30. Part A, it asks to find how many cars pass through the intersection over a 30-minute period. So to find the total amount of cars, you have to take the integral from 0 to 30 of f of t. When you plug that in, it's the integral from 0 to 30 of 82 plus 4 sine of t over 2 dt. And since this is the calculator section, you can just plug it into your calculator and you'll get 2,474 cars. Part B, it asks whether the traffic flow is increasing or decreasing at t equals 7. And to find whether the function is increasing or decreasing, you have to take the derivative of f of t. And for that, 82 will become 0. And for sine, you will go 4 times the derivative of the inside times the derivative of the outside. And that will equal 2 cosine of t over 2. To find whether it's increasing or decreasing at 7, you will take f prime of 7, which is 2 cosine of 7 over 2. And when you plug that into your calculator, you get about negative 1.873. Now, because the derivative is negative, that means that the traffic flow is decreasing. Now, to give a reason for your answer, you will write the traffic flow is decreasing at t equals 7 because f prime is negative. Part C, it asks for the average value of the traffic flow over the time interval 10 to 15 and indicate the units of measure. The formula for the average value is 1 over b minus a times the integral from a to b of the function. Now in this case, a will equal 10 and b will equal 15. When you plug that in, it will be 1 over 5 times the integral from 10 to 15 of 82 plus 4 sine of t over 2 dt. Now again, when you plug that into your calculator, you will get about 81.899. And the units will be cars per minute. Now last, part D. What is the average rate of change of the traffic flow over the time interval 10 to 15 and indicate the units of measure. The formula for the average rate of change is f of b minus f of a all over b minus a. Now again, a will equal 10 and b will equal 15. When you plug that in, it's f of 15 minus f of 10 all over 15 minus 10. And when you plug that into your calculator, you will get about 1.518. And for the units, it's cars per minute squared. Of this problem, in part A, you will get 1 point for the limits, 1 point for the entire integral, and 1 point for the correct answer. In part B, you will get just 1 point for the correct answer with the correct reasoning. And then in part C, you will get 1 point for the correct limits, 1 point for the correct integral, and 1 point for the correct answer. And in part D, you will get just 1 point for the correct answer. And at the end, you will get 1 more point if you have the correct units for parts C and D. And in D is where the cars per minute squared, and in C was just the cars per minute. In order to carry out the calculations in this problem, you need to know how to set up an integral on your graphic calculator. To do this, you'll press alpha, window, 4, and put in your bounds. In our case for A, it was 0 to 30, and then you put in your function. For us, it was 82 plus 4 sine of t, but on the calculator it will be x, divided by 2. And then you have to tell the calculator what to solve for. Here it's x. And press enter. And you get 2,474. If you're still needing help with some of these problems, some good ones to look at are number 2 from the AP packets, 2005 and 2009, and some good book problems are on page 410, numbers 18 and 20, page 295, numbers 9 through 18, part A only, page 445, numbers 1 through 8, and page 152, number 43, part A.